Welcome to Ask and Learn.
So in this question, we're asked to construct truth tables for 6 different compound propositions that are given to us. We could start off with the first compound proposition, A, which is P, conditional statement, negation of Q. So we could start off with the individual propositions. We have P, we have Q, and we have the negation of Q. So we need proposition Q in order to find the negation of Q. So we'll write down the different truth values: true, true, false, false, true, false, true, false. Now we know that the negation of Q is the opposite of Q. So if it's true for Q, it'll be false for the negation. And then if it's false, it'll be true. False, true. Now we're going to write down the compound proposition that's given to us. So P, conditional statement, negation of Q. So we know with the conditional statement that if this proposition is true and this proposition is false, then it'll be false. Anything else, the truth value is true. So we'll look at the first and the third columns to solve for this. So here we have true, false. We know that is false. We have true, true. That'll be true. We have false, false. That'll be true as well. And then we have false, true. That'll be true. So this will be the truth table for the first compound proposition. Now, let's look at B. So let's get rid of A. Let's get rid of this one. And if we look at B, let's write it down. Negation of P, biconditional statement, Q. So from this compound proposition, we know that we need to write down 3 different propositions. So it'll be P, Q, and it will no longer be the negation of Q, but it will be the negation of P. So let's get rid of this column and replace it with a new one, which will be the negation of P. So the negation of P will be opposite of P. So this is true, true, false, false. This will be false, false, true, true. Now let's write down the compound proposition, negation of P, biconditional statement, and Q. So we know that with the biconditional statement, both propositions need to have the same truth values in order to be true. If they differ, it'll be false. Therefore, we're going to look at the third column and the second column. So these differ, so this will be false. These both are false, so this will be true. These both are true, so this will be true as well. And these both differ, so this will be false. So this will be the truth table for B. Now let's get rid of this and solve C. Get rid of that one. Let's get rid of this. Let's write down C. So C, we're given P, conditional statement, Q, inclusive OR, negation of P, conditional statement, Q. So again, we see, looking at the compound proposition, we have 3 variables, or 3 different propositions. We have P and Q, and then we have the negation of P. So we'll rewrite it. And again, this will be the opposite of whatever P is. True, true. Now, let's solve the first compound proposition. So we write that down. P, conditional statement, Q. Again, we know that the conditional statement If the first proposition is true and the second proposition is false, it'll be false. Anything else, it's true. So we're looking at the first two columns for this one. So true, true, it'll be true. True, false, it'll be false. And then it's false, true, that'll be true. And false, false, that'll be true. Now let's look at the second compound proposition. Let's write that down. The negation of P, conditional statement Q. Again, if the first proposition is true and the second is false, it'll be false. Anything else, it's true. So now we're looking at the third column and the second column. So the third one, it's false, true, you know that'll be true. False, false, you know that'll be true. True, true, true. True, false, that'll be false. Now we write down the complete compound proposition. So it's P, conditional statement Q, inclusive or, negation of P, conditional statement Q. So we know that for the inclusive or, each proposition can be true. They both could be true in order to be true. If they're both false, then it's false. So we're looking at this column and this column. So true, true, we have true. False, true, we have true. True, true, we have true. And true, false, we have true. So this is a truth table for C. Now let's get rid of this to solve for D. Gone. Now D, we have P, conditional statement Q, and negation of P, conditional statement Q. So again, if we look at this compound proposition, we have three different propositions. We have P, Q, and the negation of P. So let's write that one down. False, false, true, true. We know this again because the negation of P is the opposite of P. So whatever the truth value of P is, the negation of P truth value is opposite. Now let's write down this first compound proposition. P, conditional statement Q. Second one is negation of P, conditional statement Q. And then all together, P, conditional statement Q, and negation of P, conditional statement Q. So this first one, again, if the first proposition is true and the second one is false, then it is false. Anything else, it's true. So we're looking at the first and second columns. The first row is true, true, so that's true. True, false, so that's false. False, true, that's true. False, false, that's true. Now, next column, again, if the first proposition is true and the second one is false, then it's false. Anything else, it's true. So we got to be careful when we read this. We always have to read the first proposition first. So here we see false, true, that's true. False, false, that's true. True, true, that's true. True, false, that's false. Now, the complete compound proposition, when it's an and, they both have to be true. If any one of them are false, or if they're both false, then it's false. So true, true, we have true. False, true, we have false. True, true, we have true. And then true, false, we have false. So this is the truth table for D. Now let's get rid of this to solve for E. So we know that E is P, biconditional statement Q, inclusive or, negation of P, biconditional statement Q. So again, looking at this compound proposition, we have three different propositions: P, Q, and the negation of P. So we'll just write the truth values for the negation of P real quick. Now we're going to write each individual compound proposition. Solve for those first. P, biconditional statement Q, then negation of P, biconditional statement Q, and now all together it is P, biconditional statement Q, inclusive OR, negation of P, biconditional statement Q. All right, now let's solve for the first one. So biconditional, both truth values have to be the same in order for it to be true. If they differ, then it's false. So we're looking at the first two columns. So we have true, true, so that's true. True, false is false. False, true is false. And false, false is true. Now we're going to look at the third column and then the second column. Again, both truth values have to be the same in order for it to be true. So false, true, that's false. False, false, that's true. True, true, that's true. True, false, that's false. Now, all together, remember that the inclusive OR, if they're both false, it's false. Any other combination, then it's true. So we're looking at the fourth and fifth columns. So true, false, true. False, true is true. False, true is true. And true, false is true. So this would be the truth table for E. Now, let's get rid of some of this to solve for F. So we know that F is given to us as the negation of P, biconditional statement, the negation of Q, biconditional statement, P, biconditional statement, Q. So there are biconditional statements everywhere. All right, so by looking at this compound proposition, we know that we have four different individual propositions. So we have P, Q, the negation of P, and the negation of Q. So let's solve for those. Again, negation of P is the opposite of P's. So it's false, false, true, true. And the negation of Q is the opposite of Q. So it'll be false, true, false, true. Now let's write each individual compound proposition to solve for those in order to solve for the complete compound proposition. So the negation of P, biconditional statement, negation of Q, P, biconditional statement, Q, and then the all together. Negation of P, biconditional statement, negation of Q, biconditional statement, P, biconditional statement, Q. All right. So again, for biconditional statements, both truth values of the propositions have to be the same in order for it to be true. So let's look at the negation P and negation Q. So these two columns, false, false, true, false, true is false, true, false is false, true, true is true. Now we're looking at the first two columns in biconditional statements. True, true is true, true, false is false, false, true is false, and false, false is true. Now, all together. So we're looking at these two columns. True, true is true, false, false is true, false, false is true, true, true is true. So this will be the truth value for F.